Welcome to another workshop with AR Cloud Challenge at AWE. And we have Immersal, another tech partner of Open AR Cloud Association. Immersal, Mikko Karawan is his Chief Product Officer. And Immersal, congratulations to you guys about the recent acquisition. They're now part of Hexagon. So Mikko, please start your presentation.
Okay, hello everyone and welcome to the AR Cloud Challenge. My name is Mikko Karvonen, Chief Product Officer at Immersal, and we are or have been one of those AR Cloud startups for about 5 years. But as Ali mentioned, we got acquired recently in July by Hexagon, and how this shows is mostly in our logo in the top left corner. So it says Immersal part of Hexagon now. So what this means is we will continue as an independent entity working as we have now, but with some bigger muscles behind us. So many times when bigger companies are adopting startup technology, they might be scared that the startup will go bankrupt or they will get acquired and then the technology will disappear overnight. This has actually happened with several other AR cloud companies before us, such as Blue Vision Labs was acquired by Lyft and Scape by Facebook and 60AI by Niantic. So the good news with Immersal is that we're not going anywhere. Our SDK and service works and is available and will be. So
great to know. Great to know all about that, Mikko. Great news.
Yeah, thank you. So AR Cloud or Metaverse or whatever you call it, we call it spatial mapping and visual positioning. And we want to enable it for everyone, everywhere, and on every device. And I will read this explanation. A spatial map is the machine-readable 3D map for computer vision. It enables GPS-like hyper-accurate visual positioning for any device using only a camera image. In augmented reality, spatial maps are used to synchronize virtual content with the real world, and they make persistent virtual content possible. The content can be shared with others and stays in the right place and orientation regardless of the device it is created or viewed with. This is what our core technology is meant to solve. I'm gonna say a couple of words about the company background. So we started basically in 2016, and we were already doing large-scale AR back then, but using AR markers, as you can see in the image on the left, huge 1 meter times 1 meter markers placed on the ceilings of a huge exhibition hall, and that made the computer vision work. And this was before ARKit or AR Core. But of course, this solution didn't really scale very well. We had to manually place the markers and place them in Unity and measure the locations and so forth. It was a lot of work, but many of the core technology already worked back then in 2016. Then ARKit and AR Core were released. That gave us like local tracking, as we like to call this, SLAM tracking they provide, because they don't give you the global coordinates and no persistent AR. But anyway, around that time we started to work on our own technology and wanted to get rid of the markers and basically use the whole world as the marker. And later on, the term AR Cloud was coined, which pretty much defines what this is all about. And so we released the first version of our SDK in 2019 at AWE in California. And so we've been available for over 2 years now. And in July, we got acquired and will continue to work on the SDK and our product. A general overview of our product. It's basically a two-part solution, Immersal cloud service and the SDK, which uses the cloud service. The cloud service is used to build spatial maps. Spatial maps are the core of the Immersal solution. They're the machine version of the physical world used for visual positioning. And we support many mapping devices. First, iPhones and Androids that were ARKit and ARCore capable, but now also some handheld scanners like the Leica BLK2Go, which is also part of the Hexagon group. And other devices can be supported through our open cloud service REST API. So basically, you can use whatever JavaScript, Python scripts to submit images to our REST service, and it will generate maps. And support for panoramic 360 cameras is in development and testing in progress right now. The second part of our product is the visual positioning part. So basically any device with a camera, the camera intrinsics can be used to accurately position the device in the global AR cloud coordinates. We used the pre-constructed spatial maps to localize the devices, and with then we can position virtual content in the place and tie it to the physical locations with very good accuracy. And this currently works on all AR-capable iOS and Android devices, and we also support some headsets like Nreal, Magic Leap, and HoloLens. Well, HoloLens support is in the works, but over 1 billion devices worldwide supported. And many of these solutions only support on server localization, but our product supports both on device and cloud-based visual positioning. So we have a native code plugin for all these platforms, which can be used locally. So you don't even need to have an internet connection for this to work. Workflow overview. Basically, you start with mapping a physical location. In the past, this was done with your mobile phone, taking pictures of the environment and sending them to our cloud service, which then constructs a map which can be used for localization. Then after mapping, you typically import the map into Unity or some other engine where you can create 3D content, and you can then place the augmentations in relation to the map. And then when you publish the final app, all the AR content will be tied to the physical locations where they're supposed to be. I'll try showing this video on YouTube. So here we map a cinema. We start outdoors, then get to the lobby, continue mapping. And this is the point cloud, well, of Helsinki, basically. Then we can import the point cloud in Unity and start placing content. So then when the user starts the app in front of the movie theater, the content will show up immediately. And here we have some multi-user gaming. And indoor navigation, and so forth. So that was a quick one. There are a lot of videos on our YouTube Immersal channel, so please do check them out. Some use cases for spatial AR. Well, public spaces, for example, is to use AR navigation. Industrial applications, AR assisted maintenance. This could be done with the HoloLens, for example. And of course, entertainment, gamified AR experiences, even at city scale. And advertisement and infotainment. You can show relevant interactive virtual content in location to the users. Some of these use cases, this is a collaborator of ours, Fly AR, who used our technology to create this BIM model app for a Finnish construction company, Caverion. Basically, they mapped their whole headquarters office and they had the BIM model of the office. So you can see all the pipes and everything behind the walls in correct places. And then there's indoor navigation and also these maintenance request tickets. It's just a proof of concept, but it worked really well. And there's also a video on YouTube, which we can see. So you can toggle these layers on and off if you want to see the pipes or the stuff under the floor. And here's the maintenance ticket. And this is recorded on an iPad. Here you can see behind the walls, and you can toggle some layers on and off. Yeah, we were really happy about the end result, and especially because it wasn't done by us, but by someone else using our technology. So we were very happily surprised to see this actually work. Okay, I'm not gonna, well, it ended. And then in entertainment, we've had some like stadium size proof of concept projects, games that you can play when there's a pause in the game, some entertainment, and then some treasure hunt. And this is actually by some company who used our technology to create an AR shooter game that worked in this on the streets of a city. Really impressive stuff. And some projects done by our users. Like I'm gonna show maybe this one. So this is like a visualization of some buildings that are not yet constructed, but you can see them, or they're gonna look on site. So they have basically mapped this area of the city and added some virtual buildings there. Actually, very nice use case. Some of the features of our SDK. So basically it's a mapping and localization service and SDK, easy and affordable. It provides detailed and scale precise maps for all locations, indoors and outdoors. It can be used in AR hotspots and also in massive city scale experiences. It allows for persistent AR experiences across devices, different platforms. It's ready for multi-user apps. We even have a simple multi-user example coming with the SDK, but basically any multi-user server can be used with our SDK to provide that kind of capabilities. We support both private and public maps, and the maps can be shared with other users. We mainly have samples and documentations for Unity. There are also some native iOS samples available, and hopefully more samples for Unreal and Unreal Engine and Android and HoloLens in the future. WebXR support will come as soon as device manufacturers support the standard. And I can tell you now that in our forthcoming SDK 1.14 version, we will actually support WebXR on Google Android in the developer portal, where you can look at your maps and localize them so you can see them immediately on location in your web browser on your mobile phone. So that's an exciting new feature coming up, but unfortunately WebXR doesn't work on iPhones yet, and so we still have to wait, hopefully not for too long, for the standard to really pick up. Some core advantages of our SDK. It provides efficient spatial mapping with support for many device types. For example, we mapped 1 million square meters of the Helsinki city center with just 2 people in under 20 hours. So basically anyone can do that, and it doesn't cost that much. Our solution is very lightweight and robust, saves your battery life, and you don't need to run it every frame. Basically, we rely on the device tracker, ARKit, or HoloLens, or Magic Leap, whatever, between the localizations. So it's enough to localize every, let's say, 2 seconds or 5 seconds. And if the device tracker drifts, our localization will correct the drift, and so it's pretty seamless. We support localization against multiple maps at the same time. So you can, for example, map a larger area in parts, and then you can localize against all the maps. We also support manual and automatic merging of maps. They can be stitched together or aligned either automatically or in Unity manually. The accuracy is excellent, up to 2 centimeters indoors and about 15 centimeters outdoors. Localization speed is very fast, about 100 milliseconds on newer iPhones, and actually the on-server localizer is even faster, but then there's of course the round-trip time from the network traffic. And we have a feature which we call visual GPS. You basically get your latitude and longitude coordinates from the image, and this can also be called geopose. So you don't need satellite-based GPS at all to get your location in global coordinates. Our map file size is efficient. Like for example, this 9,000 square meter outdoor map is less than 3 megabytes. So even if you're on a mobile phone, you can download these maps on your device if you don't want to use the on-server localizer. Our solution is scalable. The server supports several users at the same time, and there's a load balancer and everything, so it scales up nicely.
Hello?
And as
You
said,
down
we
there? No.
Okay, so we support both on server and on device visual positioning, and the core technology is highly optimized C and C++. And I'm going to talk about our pricing a bit. We have a free commercial license available for developers to get started, and enterprise license with full control of the data and enterprise level mapping device support is available. So everybody can start with the free commercial license. It can be used in your commercial projects as well. There are some limitations, like only 300 images per map, 1,000 maps per month, one simultaneous map construction, etc. And we also offer a free non-commercial enterprise trial, where we have some nice add-ons like the HoloLens 2 plugin and support for the Leica BLK2Go mapping pipeline. And this can be tested by enterprise clients before they make the final decision of actually purchasing a license. And then, well, the last one is the self-hosted license, where we don't own any of the map data. We don't ever see it. The client can host the whole service on their own servers. This can be easily deployed with Docker images to any server imaginable. So this is it from me. Well, actually, I'm gonna quickly show something. This is the room where I'm actually sitting in right now. I mapped the room quickly by taking 39 images, and you can then view the maps in our developer portal. This is the point cloud representation of the map, and this is the texture mess. Well, here it is. Hold on. Yeah, this is the room where I'm right now. So this is something that you can also get as a byproduct of the mapping process. It's a nice visual gimmick, but these can also be used for real-time occlusion. And also in our next SDK version, you can view these in the AR mode. So when you go to the dev portal, you can open this point cloud and localize it, and then you can see if it matches with the environment or not. Okay. So to get started, go to developers.immersal.com, create an account and download our free SDK for Unity and start working on your amazing AR apps. Thank you.
Thank you very much, Mikko. Here's a question. You
Yes.
said the localization can happen both on the device and on the cloud. So can you elaborate, like you're actually having the point cloud in the device at that moment when you're doing it on the device?
Yes, we load the map in the device. As I also said, that the map file size is quite small, that you can load like 3 megabyte maps on the device and then localize on the device and not using the network at all. And you can also do like hybrid localization. First localize on the cloud. When you get a match, you can also get the map ID, which you can then download on the device and do the subsequent localizations on device. And then you will save network traffic. I don't
And a
know.
hybrid.
It's a bit faster if you have a slow network connection. The localization can take some time. On device, it takes just some milliseconds.
Perfect. Thank you very much. So I'm checking the chat. If anybody has any questions, it is the time to ask. And Miko, thanks a lot for the presentation, and very instructional now. As we are coming to the end of the workshops, I'm also checking if there's any question. Please, let's continue if you have any questions, but as we're coming to the end of the workshops, now it will be time for participating on Discord channel, asking us questions. If you're interested to become tech partners with any of our great, amazing tech partners, it's time to communicate with us on Discord. We have the Discord invite, and you can find that. If you cannot, please reach out to me on Discord. You can find me, or any of the organizers will be contacting you and helping you to connect with the right tech partner. And I still don't see any questions, Miko. So thanks a lot again. And
Thank you.
yes, we'll be on Discord.
Yes, I'm there as well.
Yeah, Miko is on there as well. Yeah, please reach out to him as well. Yeah.
Yes. Something in the chat, no?
No, that's just thanking you. And
yes.
This is the end of our session today. Goodbye, everyone.
Okay, thank you. Bye-bye.
Bye.